Hey everyone, my name is Kevin, and today I'll be going over network science to correlate COVID-19 and tourism indicators in Mexico. So, network science is a field used to study complex systems by analyzing the connections between their elements. In this paper, the researchers analyzed Mexican tourism as a complex system affected by the COVID-19 pandemic using network analysis. The researchers applied network science to uncover insights into how tourism indicators correlate with COVID-19 impacts. So some of the objectives were to confirm the value of network analysis in understanding tourism dynamics by focusing on occupancy rates, hospitality and gastronomy jobs, and their correlations with COVID-19 confirmed cases. Second was to use network analysis to review centrality measures and to uncover key patterns in tourism and pandemic data. Third was to identify key tourist destinations that sustain travel demands and contributed to employment during the pandemic. Some of the research questions were: how did COVID-19 impact tourism occupancy rates and employment jobs in Mexico? Which tourist destinations concentrated the bulk of tourism? Which tourist destinations demonstrated resilience during the pandemic? And how did the network structure of tourism change during the pandemic disruption? In 2019, tourism played a pivotal role into Mexico's economy, contributing 8.7% to the GDP and provided over 4.2 million jobs. However, the global pandemic changed everything. By February of 2020, Mexico reported its first case of COVID. To contain the virus, Mexico implemented strict measurements in April of 2020, which included flight suspensions and quarantine protocols, which had dramatic effects on tourism activities. The tourism indicators are Mexican tourist destination occupancy rates and hospitality and gastronomy jobs. The COVID-19 indicators are the confirmed cases in Mexico. The data was collected from three different sources: Datator for hotel occupancy rates, INEGI for employment statistics, and COVID-GOB for the confirmed case counts. To analyze the data, NetDraw and UCNet was used for network visualization, and parallel modeling was used to detect hubs and patterns in the tourism network. Metrics like degree centrality, closest centrality, and between centrality were used to identify key patterns in the tourism network. So, COVID-19 traveling restrictions began around April of 2020. In this analysis, they examined the occupancy rates from January to March of 2018, 2019, and 2020 to show the pre and post COVID trends. The researchers applied two-mode centrality, which is a bipartite network metric that measures the importance of nodes connecting um, the occupancy rate clusters, which are the squares, and the tourist destinations, which are the circles, to identify the key clusters and connections in the tourism network. Next, degree centrality was used to pinpoint the most influential clusters and destinations. So figure 8 shows the accumulated occupancy rates from January to March of 2018 before the pandemic using degree centrality. The results show that the 51 to 60.9% range cluster had the highest degree centrality, which concentrated to the bulk of tourism on 20 destinations, including Oaxaca, Campeche, and Laredo. And these clusters were critical nodes to the tourism network, which reflects their high importance. The maximum occupancy rate was achieved by destinations like Playa del Carmen and Puerto Vallarta at 86 to 90.9%, which reflects their role as the more popular tourism hubs. So figure 9 represents the 2019 version, and the results show that the highest degree centrality for occupancy rates was between 46 to 50.9% range, and this concentrated the bulk of tourism on 12 destinations like Oaxaca, Campeche, and Laredo. And compared to the previous year, there's a slight decrease. Nuevo Vallarta stands out with the maximum occupancy rate of 86 to 90.9% range, making it a key hub for tourism. But despite the changes, some destinations like Playa Ca, Puerto Vallarta still maintain high occupancy rates of 81 to 85.9% and still continue to act as critical hubs. So the first COVID-19 case was detected in Mexico on February 2020, and in Figure 10, which is the 2020 version, you can see that it had some initial impacts on the occupancy rates from the early concerns about the pandemic. The results show that the highest degree centrality for occupancy rates was between 36 to 45.9%, and this represented the bulk of tourism on 22 destinations like Oaxaca, Campeche, and Laredo. And these destinations represent the resilient nodes in the network after maintaining moderate activity despite the onsets of COVID-19. In the previous year, Nuevo Vallarta registered the highest occupancy rate of 86 to 90.9%, and this decreased down to 76 to 80.9%. So there's a 10% decrease. So Figure 11 focuses on the destinations that concentrated the bulk of tourism in the three periods. So the red nodes represent the important destinations for a specific year's cluster, and the brown nodes represent the robust destinations since they appear consistently across multiple clusters over the years. They also demonstrate resiliency and importance by consistently attracting tourists and are the key tourist destinations in Mexico. So a separate analysis was done for April and May because they wanted to evaluate the impacts of COVID-19 when flight restrictions were in place, which happened around April of 2020. So figure 12 corresponds to April of 2018. The highest degree centrality for occupancy rates was between 46 to 55.9%. And this captured the bulk of tourism on 20 destinations like Chihuahua, Tijuana, and Acapulco. Akumal registered the highest occupancy rate, which was 91 to 95.9%, which means that it's a key tourism hub. And figure 13 corresponds to April 2019, and the highest degree centrality for occupancy rates were between 41 to 45.9% and 61 to 65.9%. And this concentrated the bulk of tourism activity on 21 destinations like Mexicali, Taxco, and Meridia. And Playa Car had the highest occupancy rate, registering between 86 to 90.9%, meaning it's a key hub. And figure 14 corresponds to April of 2020, and you can see the pandemic restrictions starting to take place. The highest degree centrality for occupancy rates were between 0 to 5.9% in most destinations, and Mazatlan had the highest occupancy rate of 16 to 20.9%, and this was significantly lower than previous years. So as you can see, there is an impact of COVID-19 on occupancy rates since there's a significant decrease across multiple destinations. And this is the analysis done for May. Figure 15 corresponds to May of 2018, and the highest degree centrality for occupancy rates were between 41 to 45.9% and 51 to 55.9%. And this concentrated to the bulk of tourism activity on 19 locations, including Ion and Mazatlan. And the highest occupancy rates were registered by Playa Car and Acumar at 86 to 90.9%. Figure 16 corresponds to May of 2019, with the highest degree centrality for occupancy rates between 51 to 55.9% and 61 to 65.9%. And this concentrated to the bulk of tourism activity on 19 locations like Mexicali and Tijuana. The highest occupancy rates were registered by the same two locations, Playa Car and Acumar at 81 to 85.9%, which dropped around 5% from the previous year. So this suggests that Playa Car and Acumar are the more popular and resilient tourism hubs. And figure 17 corresponds to May of 2020, and you can see the impacts of COVID-19 on tourism. The highest degree centrality for occupancy rates were between 0 to 5.9% on seven destinations like Valle de Bravo and Oxana. The highest occupancy rates registered were in Celaya and Ciudad Juarez with 11 to 16%, which were significantly lower than pre-COVID levels. So you can see that tourism was negatively impacted for most destinations, which reflects the economic and social consequences of lockdown measures. Table 3 contains the metrics for tourist destinations that concentrated to the bulk of tourism from January to March of 2018, 2019, and 2020. So degree centrality measures the number of connections a tourist destination has with other tourist destinations in the network. 2 local centrality represents the mode network as a bipartite graph with balanced incoming and outgoing links. So it not only considers the direct connections but also the connections of neighboring destinations. Eigenvector centrality shows the robustness. It measures the influence of a destination based on the importance of other neighbors. Betweenist centrality measures the information control and highlights the destinations that serve as information control hubs. So from this table, the degrees show that the most common occupancy level registered by destinations across all periods was 46 to 50.9%. So overall, you can see that January, March of 2019, it represents the most robust period in terms of network metrics, which highlights the strong tourism dynamics. And in January, March of 2020, it shows a clear decline across all metrics due to the pandemic's impact on tourism activity and it weakening the network's interconnections. So the researchers stated that identifying the states with the most tourist destinations is useful to getting insight for tourism recovery strategies after COVID-19. Figure 18 is the correspondence between the states and the tourist destinations, with the squares representing the states of Mexico and the circles representing the tourist destinations located within the states. And Table 4 reviews the degree centrality for each Mexican state in the network of tourism destinations, and it shows that Puebla is the state with the most interconnected tourist destinations in the network. So Puebla's high centrality makes it a strategic candidate for prioritizing post-COVID recovery efforts. And by focusing resources and policies towards restarting tourism in Puebla, it could yield potential economic and social benefits for Mexico. So moving on to the correlation between employment and COVID, Figure 19 shows the two mode centrality network of states linked to employment ranges in the hospitality and gastronomy sectors in the Mexican territory by April of 2020. 5 employment ranges were identified from scarce to maximum, and from this, along with Table 5, the researchers found that most states classified on few employment ranges, and that Baja California reported the maximum employment range. And Figure 20 shows the two mode centrality for COVID-19 confirmed cases in Mexico by June 2020. So 4 ranges were identified from scarce to maximum, and from Table 6, the researchers found that most states fell under the low-level range of confirmed cases, and also found that Mexico City had the maximum level of confirmed cases. And this information is useful for planning a safe and responsible restart for tourism by identifying the least affected destinations so that Mexico can focus on promoting these areas and rebuilding trust with travelers while developing strategies to support the destinations with the most cases. So Figure 21 combines both Figure 19 and Figure 20 to consider both employment and confirmed case ranges with their corresponding states. And what we can see is that most states and destinations reported low levels of COVID-19 confirmed cases. Along with this, we can see that Mexico City was impacted the most, which experienced maximum confirmed cases with an abundant hospitality and gastronomy jobs. So this means that most confirmed cases are correlated with high employment. So you can see Campeche, it reported moderate levels of hospitality and gastronomy jobs and scarce confirmed cases. In Oaxaca, it reported moderate hospitality and gastronomy jobs with low confirmed cases. In Baja California, it reported maximum hospitality and gastronomy jobs with moderate levels of confirmed cases. So this supports the correlation that areas with abundant jobs correlate with higher confirmed cases, and scarce employment correlate with lower confirmed cases. So Table 7 shows the metrics for states by employment and confirmed case ranges, with most states classifying low levels of confirmed cases with few hospitality and gastronomy jobs from the degree metrics of 0.43 and 0.4. And if you look on the two mode centrality, it's 0.18 and 0.16. So there is a correlation between confirmed cases and employment rates, which is proven through the low degrees and two local metrics for regions with maximum hospitality and gastronomy jobs, as well as confirmed cases. So this table supports the correlation that areas with higher employment correlate with higher confirmed cases, and areas with scarce employment correlate with lower cases. So researchers wanted to analyze the occupancy levels of different months and different years to better understand the underlying distribution pattern. And under normal conditions without COVID-19, destinations that concentrated to the bulk of tourism behaved accordingly to the power law, making their dynamics predictable and structured. So in equation one, they described the probability of a tourist destination exceeding a specific level of occupancy, and demonstrate that occupancy behaviors follows the power distribution law under normal conditions, which is pre-COVID. Equation 2 represents the degree distribution of a scale-free network and highlights the hierarchical organization of destinations where small destinations are integrated into larger networks. Figure 22 is a log-log plot of the occupancy level distribution in Mexico over a course of 4 periods, which are April of 2018, April of 2019, May of 2018, and May of 2019. So the x-axis represents the probability of occupancy levels, and the y-axis indicates the percentage of occupancy levels in a tourist destination. And each point indicates a specific occupancy level for a given time period. The logarithmic scaling on both the axes reveal the power law behavior with a consistent slope of negative 0.212. So it indicates that there's a statistical invariance of occupancy distributions over time. And the similar trends across different months and different years confirm the distribution of visitors is stable and predictable. So the findings support the two generic properties of social networks and tourism dynamics. First is free scale topology, and this implies that small destinations are organized hierarchically into larger groups, ensuring robustness. Second is high clustering degree, and this means smaller destinations tend to cluster around larger hubs, enhancing the network's resilience. Despite the differences in periods or destination types, tourism occupancy is non-random, and this reinforces its nature as a complex system. All in all, the analysis confirms the bulk tourism destinations are governed by the power law dynamics, and this ensures the stability and predictability in visitor patterns. In Figure 23, researchers analyzed the correlations between confirmed cases and the reductions in tourism. And the results show that by May of 2020, destinations with moderate levels of confirmed cases experienced significant reductions in tourism occupancy, with the most affected destinations recording occupancy reductions between 1 to 5.9%, with Puebla being the most impacted state. In Table 8, it provides the degree measurements of confirmed COVID-19 cases and the occupancy reduction. If you look at moderate confirmed cases, it shows that the highest degree measurement is at 0.42, which indicates a strong correlation with significant reductions in tourism occupancy. If you look at occupancy levels between 1 to 5.9% on April of 2020, it has the degree measurements of 0.23, which confirms the correlation of low occupancy with the pandemic. And finally, if you look at Puebla, it has the degree measurements of 0.14, which highlights its central role and vulnerability within the tourism network during this period. So the results show how the pandemic significantly disrupted the tourism network, with moderate levels of confirmed cases being indicators to reduce tourism activity, while low occupancy rates in vulnerable states like Puebla were being impacted the most. And these insights will be useful towards targeted recovery strategies. By focusing on regions that were hit the hardest and addressing the weaknesses in the tourism network, the tourism sector can improve for the future. So in conclusion, this research paper confirms that there is a strong correlation with the confirmed cases and the reduction in tourism occupancy rates. The occupancy rates dropped to 0 to 5.9% for many destinations in 2020. Oaxaca, Campeche, Loreto, Nuevo Leon, and Baja California were the most resilient destinations, maintaining moderate levels of activity despite the impacts of the pandemic. Loreto, Campeche, San Juan de Rio, Oaxaca, and Durango were the most robust destination by ensuring consistent tourism flows across all periods, pre-COVID and post-COVID. And we also found out that Puebla was the most impacted state with an occupancy rate of 1 to 5.9%. And this research paper also confirms that there is a strong correlation between the employment rate and the number of confirmed cases, with higher employment rates meaning a higher number of confirmed cases. And Mexico City experienced the maximum number of confirmed cases and had the most abundant hospitality and gastronomy jobs.